So let's take a quick look. What I want to do first, very, very briefly, I want to review the three forms of quadratic functions. So let me get everybody's attention tightly focused up here, laser focus. Okay, the three forms of quadratic functions. One of them is general form or standard form. The textbook calls it standard form. I'm going to give you guys your books, by the way. We'll do that.
Oh, no.
I know you don't want them, but I'm going to give them to you, and you can. I want you to have them.
Will we do assignment?
No, not really. As much as I can avoid it, we won't. Okay, listen, please. Hold that for later. Okay, so standard form or general form. F of x or y equals what?
H.
No, it doesn't have h's. Ax squared plus bx plus c. Very good. Okay. Okay.
Okay, we're doing.
Okay. So on this one now, this is strangely when we're dealing with graphs like we are in this first section. This is the most inconvenient of the three. Remember, this is the one where if we want to identify a graph or sketch a graph, we always want to start with the vertex, and it has a formula that you have to know that goes with this. So what's the formula for the x-coordinate of the vertex? X equals...
Is it with the lines?
No, it's just a little formula. X equals negative... Say, what was it?
X divided by b.
Oh, it's close.
Isn't it negative x?
Negative b over 2a.
Oh.
Same thing.
Not quite the same thing, but in the vicinity, in the ballpark. All right, so now if we're going to look at a couple quick examples of these, but if we wanted to, let's say, sketch a quick graph of a quadratic function in standard form, right? Okay, we can plug in the values of a and b into that little formula, right? To find the x-coordinate. Now, what do we always do if we want to find a y-coordinate, a y value that goes with an x value? Always. Yeah. Plug in the number. We're going to find a number for x. We're going to find the value of x. Plug it into the function and calculate what the value of y is. No big deal. So once I know that, I've got the ordered pair. Whoa! Got the ordered pair that corresponds to the vertex. What does the sign of A tell us? Okay, if A is positive, what does the parabola do? The U-shaped parabola opens up. Negative, it opens down, right? If we wanted to do an accurate sketch, we could always make a t-table and plug in a value of x other than the vertex, right? Find the y value that goes with it and reflect it over the axis. Okay, so we could do that if we needed to. All right, so that's the hardest of the three. Now let's get a little bit easier here. Vertex form. Vertex form, my hint is think absolute value functions. Earlier this year, we already dealt with a function in a vertex form. So this is the one where f of x or y equals, yeah. Yeah. Good. So it's a, starts with a, times the quantity x minus h squared. With the absolute value function, it was just absolute value of x minus h, right? Now it's that quantity squared, because it's quadratic instead of absolute value, plus k. Very simple to deal with. How do we find the vertex here? H and k, that's it. H, the value of h is the x-coordinate of the vertex. The value of k is the y-coordinate. A means the same thing. Positive opens up, negative opens down. Okay, and then the last of the three.
It's with the lines.
Is that's what's like the one we just looked at. Very similar. This is intercepts form or factored form. Okay, remember this one. This is probably the one that you're the least familiar with, I would guess. F of x or y equals a. Always starts with a. A times what?
B.
No. Remember this one? This is the one where it's written as a product of factor.
The x's are the interceptions on the.
Good. So the form is a times the quantity x minus p times the quantity x minus q, and p and q represent the x-intercepts of the graph, right? And so on this one, if I wanted to sketch a parabola associated with a quadratic function in this form, I identified the values of P and Q. Those are the x-intercepts. Now, the x-coordinate of the vertex is related to them how? Magic. Well, math is all sort of magic, isn't it?
Pretty much.
I need more specific. I need a more specific brand of magic here. So, yes.
Are P and Q the X, Y things?
Okay, P and Q are both x values. Those are the x values where the function crosses the x-axis, the x-intercepts, right? Now remember, the really important concept here that you got to remember is that these parabolas are symmetrical, right? They're exactly, when you cut them down the middle, they're identical on both halves. The vertex has to be halfway in between, doesn't it? So how do I find the x-coordinate of the vertex? It's going to be the middle value of P and Q then, doesn't it? So we just average them. Now let's look at a couple quick examples with actual graphs, and then I think this will make a little more sense.
Will this note be on?
Say it again.
Will these notes be on?
This is being recorded as we speak.
Okay.
Yes. Yep. Okay, so let's go ahead and get the difficult one out of the way.
No, I just want to actually ribbon.
Okay. Up here, please. So here is the function. Let me make that bigger. That's too small to see, probably. We'll make that a little larger. Okay, so there is the function. Y, or f of x or y, equals 2x squared minus 24x plus 70. So if we want to either sketch a graph or identify the sketch of a graph, identify a graph of a function, the way to do this is to identify the values of, in this case, this is in standard form, right, or general form. So I go to identify the values of A, B, and C. So we're comparing it to y equals ax squared plus bx plus c. So what's A? What's B? Good, negative 24. And C, whoops,
7.
equals 7. 7D, right? Okay?
Oh.
So then we got to find the x-coordinate of the vertex. Remember the formula?
X equals A to B divided by 2A.
Good. Okay, so if I plug in the numbers then, that gives me x equals negative b is what? 24 over 2 times 2. So 24 over 4 is 6. So we know the x-coordinate of the vertex is 6. How do I find the y-coordinate?
Plug it in.
I'll plug it in, unfortunately. So if I plug that in, yikes, what do I get? So I get y equals 2 times x, which is now 6, squared, minus 24 times 6 plus 70. So let's do that math. So 6 squared is 36 times 2, 72. So y equals 72 minus 24 times 6. Now that's a big one, but we can make that smaller. Well, we can just do it this way. What's 6 times 20? 120. 6 times 4. So 120 plus 24. 144. And it's going to be negative, isn't it? So minus 144 plus 70. Come on, don't. Everyone focus. So let's add up the two positives. How about 72 plus 70 is 142 minus 144, so it's just two extra negatives, right? So we end up with -2 being the y value, so the vertex should be at 6, -2, and the parabola does what?
Go up.
It's gonna open up, isn't it? Good. So it's gonna have that basic look to it, right? Okay, let's find that one. Tell me when one looks interesting to you. Okay, that looks pretty good, doesn't it? Okay, any others? Nope, that's the only one, right? Yeah, let me get everybody turned completely around, up facing the front up here. Thanks. Okay, now, there's one possible dilemma, though. We identified it. But sometimes, these questions are going to get pretty sneaky. And sometimes you're going to end up with more than one parabola that has the correct vertex. So the question is then, here's the question. How do we know which is the right one? Okay, a couple ways we can do this. Now I'm going to show you a trick, first of all. We could always plug in the coordinates of another point and see if they work. That is an infallible, foolproof way of checking. So for example, if I were to take, let's take this point right here, whoops, point right here, that has coordinates x equals 5, y equals 0. We could check that. I could plug 5 into my function and see if I get back 0 for y. And if I do, I know I got the right one, because I already identified it has the right vertex, then would also have the right shape if one of those other points worked also. Does that make sense? So I can always check another point and see if it works. But there is a little trick here. The trick is the value of a. A is sort of like a slope in a way. It's not a slope, but it's kind of like a slope. A tells you, when you're working with parabolas, if I scoot to the right by 1, it tells me how much the y value will change. In other words, if this is the vertex, if I scoot to the right by 1, then however much the parabola increases or decreases, that amount is a. Okay, so look at our parabola down here. If I scoot to the right by 1, do you see that I increase by 2? So that means a is positive 2, which it is. Does that make sense? So we identified the vertex, and it has the right a value that matches that point that's 1 to the right. That's just kind of, you don't have to do it that way, but it's a nice little shortcut if you want to use it. Okay? Questions? Okay, from here, it's a piece of cake. That's the hard one. So now the rest of them are much, much easier. Let's quickly look at a vertex form. Okay. Okay, I want you guys to do a little better job of, listen, we talked about this once before and it was great for a long time, but it's kind of degraded a little bit. When occasionally I got to pull up another problem or something. What I do not want to have happen, and I want you to try to do this on your own, without any intervention from me. Just don't get sidetracked. It wastes time for all of us. That's just not a good plan. So just stay on task in here. In the lab, things are much more laid back. Okay, so now, what form is this? Which pattern does that match of the three? Which one? Okay, the one that's like the absolute value bars, so it's the vertex one, right? The one with an H and a K in it, right? Okay, so this is the form we're comparing it to. Y equals A times the quantity X minus H squared plus K, right? So what's A? Negative 1/2. Okay, so that tells us it opens down. And if I move 1 to the right, how much should Y change? It should go down by 1/2. Yeah, the Y value should only go down by 1/2 if I scoot to the right by 1, if you want to use that trick. Okay, what about H and K? h equals, you gotta be careful with this one, 3, right? Because h is being subtracted from x, it's always the opposite of that sign in the middle, right, that operation. So it's positive 3, and k is easy. What's k? Negative 8. So the vertex then is at x equals 3, y equals negative 8, it opens down, and a equals negative 1/2. That should be pretty easy, right? This one is much easier. So positive 3, negative 8, does that look good, maybe? Right there, over 3, down 8, look good? And furthermore, if you look real closely, if I scoot to the right by 1, I drop by about 1/2. If I really wanted to check accurately, I could take the coordinates of that point and plug them in and see, right? But it looks pretty good. From the choices that I've got, that one really seems to fit, doesn't it? Does everybody get what I mean by that over 1 bit?
Yes.
Okay. All right, so one last one. Let's do a intercepts form, and then we'll go to the lab.
Do you like your desk sweater, or
No,
do you just not have enough time?
exactly. You nailed it. That's exactly it.
If a week was active, where you would give us all like 100%
No.
extra
Okay.
credit?
Okay, real quick. What form is this?
The other
I guess you know. Duh. I got carried away, didn't I? Intercepts form. So we're comparing it to, and I would encourage you to, at least initially, till you get good at that, just to write down the form. I'm gonna try. It's so hard to find time to do these little things that I really want to do. But one thing I'd like to do is I'd like to put up flashcards for you on Moodle to sort of help you with this stuff. I'll try. I can't guarantee it, but I'll really try to do that in the next day or so. I mean, it may or may not get done, but it's a goal. So this is the one where it's y or f of x equals a times x minus p, good, times the quantity x minus q. So what's a? Good. P is, be careful, negative 14, good. Q is negative 12. Okay, so real quick, tell me then. Go ahead. So what is the x coordinate of the vertex going to be?
I said negative.
Negative 13. It's got to be halfway in between, doesn't it? Because it's got to have that symmetry, right?
Yeah.
So we know that the vertex is at negative 13 something, right? Now, if I want to find the vertex, all I have to do, is plug negative 13 into my function, right? It's actually pretty easy to do. It looks like it's going to be hard, but it's not, because negative 13 is going to combine with those two numbers and make relatively small numbers in the parentheses, right? So if we do that real quick, if I plug it in right here, I get y equals 4. Now, what is negative 13 plus 14?
1.
1, yeah. What's negative 13 plus 12? Negative 1. So that wasn't so bad. So I just get negative 4 for my y value, right? So let's go find this guy then. So negative 14 and 12, that looks pretty good right there, doesn't it? Okay, but it's not quite right, is it? It's very close. But look, the a value is not right. If I scoot over 1, I only go down 2 instead of going up 4, right?
Yeah.
Does that make sense? So it's not good. It's close. Very close, but it's still the wrong direction, isn't it?
Yeah.
Okay, it's opening down instead of up.
No.
Very close, but it's the wrong value of a. See how tricky these can get? And that looks pretty good. The x-intercepts are at negative 14 and negative 12. Negative 13 is the vertex. It has the right y value. It's negative 4, and I didn't even really need to find the vertex, did I, on this one? I could have just checked the value of a, over 1, up 4. There's a lot of ways you can be sneaky about this. You just got to be strategic, but you can identify the graph in a bunch of different ways, as long as you know the math. Okay, questions?
No.
We good? Okay, I gotta find a lab, which might be a little tricky. Yes, you may when we get down there.